So we want to get the heat change for this, right? And we have these three given equations, and here's FeO. Do you see any FeO anywhere? There's FeO. No more FeO, that's the only one. It's on the wrong side, and it has the wrong coefficient. So if I multiply this by a -3, the negative means I've reversed the equation and I put a 3 in front of the Fe. Oh. Okay. So I'm going to multiply it, and I can't write on my screen here. Let's see if we can see it. Oh, I can write here. So I'm going to multiply this one by -3. And then I look to see if there's something unique. And here's CO2, CO2, CO2. I'm not going to bother with CO2, it's in all of them. That's not too unique. Here's Fe3O4. I could do the same thing there, CO, 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 CO. I'm not going to work with CO. By the way, if you have one where their molecules are repeated everywhere, what do? You say A, B, C. Those are the multipliers. Then you pick Fe2O3 and you go C times 1 plus, and if you have Fe2O3 here, you go B times 3. If you have Fe2O3 in another one, you do C times whatever it is. And you have enough information to set up what?
Quadratic equation.
3 simultaneous equations. You have 3 unknowns, 3 simultaneous equations. You solve it, and then you'll know what these multipliers are. Most of the time we give you ones you don't have to do that. But that's how you would do it if all the molecules were in all of the different equations. Then you'd have to resort to something like this. But fortunately, that's not going to happen. We already took care of one of these things. We look at Fe3O4. None of it here. Oh, there's Fe3O4. And there's none here. So we can work with Fe3O4. Again, it's on the wrong side, so we need to reverse it, so we put a minus. And it has the wrong coefficient. It has a 2, and we want a 1. Minus 1/2. And you say, do we need this upper equation? And the answer is, well, if I use this equation, I have Fe2O3. There's no Fe2O3 to cancel it out here. The final equation doesn't have Fe2O3, so I have to use this one to cancel this one. Now, they're on opposite sides. I already changed the sign, so I know I have to keep them on opposite sides so they cancel out, so I need still a minus. Now, when I get done multiplying, this one is going to be -3/2 on this side. You want to keep track of where the equal sign is. So this one has to be +3/2. In other words, 3/2 here. Because if I multiply this one by -3/2, it has -3/2 O2 on the left, -3/2 Fe2O3 on the right. They cancel out. That's all I need to do. Except now I have to finish the problem. But I'm just going to prove that it works by looking at, we said CO2 was in all 3 of the equations. So in the first equation, -3/2 times 3, it's on the other side here, so it's -9/2 for the CO2. The second equation, it's 1/2. Where's the CO2? Right there. So it's -1/2 times CO2. I'm putting in my equal sign. And my third equation, 3. So this side gives me what? 2 1/2. I'm going to rewrite that as what? 5/2. Everybody's happy with that. -9/2. So 5/2 minus 9/2 gives me, oops, it's on this side, -4/2, which is what? No, I bring this, let's see. This is, oh, okay, it's not going to cancel out. I have to go minus, I'm going to leave the 5/2 here. I'm going to bring now plus 14 halves. 7. I messed up somewhere. Maybe I got the wrong multipliers. Oh, this is minus 3. Minus 3 CO2. Now I'm okay. Because what am I going to get now? This is 6 halves minus a half, so it's minus 7 halves here. On the other side I have minus 9 halves, which means I have minus 1. I bring it over here, plus 1. That's what my coefficient is. You don't have to do that unless you're not sure you got the right numbers when you worked it out. I just wanted to show you that it worked if I played with it long enough. I was sure I got the right numbers the first time around, so that's why I knew I made a mistake here somewhere. Okay? So now that doesn't finish the problem. What I have to do, of course, is say delta H, or he calls it Q. And the reason he called it Q is these aren't really the enthalpy changes you get for those reactions. If you look up delta H sub F, you get some different numbers. So Q would be minus 3 halves, parentheses, times, and that's a minus 14. This is where you do the parentheses in your change sign functions, and it's going to be plus minus 1/2, and plus and that's a minus 1, 2. And now you get your calculator out and solve. Okay, so that's Hess's. Somebody solve. Anybody have a number for me? Nobody has a number? I'll put the number if you have a number for me. See if it works. I don't want to get, I'm too lazy to get my calculator out. The number, it's the end of the period, so I just have to put it away.
36.5?
Somebody said 36.5. Oh, my no. How would we do that? Is it a minus or a plus?
Plus?
No.
Okay, so enter your answer. And we push check answer. Oh, I didn't like the first one. Oh, it's wrong.
Red wall.
What? Somebody says 35.5. Well, when that happens, what do?
You push it until you get right.
So the answer.
Oh.
And it says 1 you reverse and multiply by 2. Okay. 1 I multiply by 3 halves. Minus 3 halves. Then he says 2 you multiply by a half. I don't think he's working with the same set of equations I'm working with. What? Well, let me see what I get here. This one's going to be plus. This one's going to be minus. This one's going to be plus 3. That was easy. I could do that in my head. 7 times. This is 21. This one is what? So I have 21 plus 3 is 24 minus 11.5. Is that right? Yeah. 5. 3 minus 1 is 2. 12.5. Oh, you got 12. I got the same answer you got.
No, because then you would add.
Oh, you know what he did? When he says reverse here, he actually wrote the equation in the other direction, and then he changed the sign because, let's see, what does he have here? Reverse 2. So he multiplied by minus 2, and he got 21.